Hi guys! So for the last couple days we've been talking about functions, how we know if we have a function, and what function notation, so how we write about functions, looks like. Today we're going to talk about what are called domain and range. So just to review, a function is a pair of numbers in which each input has exactly one output. When we learned about this the other day, we said one way of thinking about this is that everyone can only go to one party. Now, when we look at functions, we a lot of times are talking about the relationship between the inputs and the outputs. So we're going to give inputs and outputs some technical names. The set of all of the inputs of a function is called the domain. Now these are the x values. These are the numbers we're plugging in. The set of all of the outputs of a function are what are called the range. We call those the range. These are what are called the y values of a function. So an example would be like this. It says in the directions, identify the domain and the range. Domain means the inputs. So if I look at this chart and I look at the rows, the first row is labeled input. The second row is labeled output. To list the inputs, we would write 10, 12, 13, 17. But then we need a special notation to show that this is a special list, not just like a random set of numbers that we came up with, but like a list that means the inputs. So we use what are called squiggly brackets around our list. Please note that the squiggly brackets are required. If you don't have them, you will lose points for notation here. Now the range would be the outputs. So if I look at this chart, the second row says 1999, 2399, 2599, and 3398. And then I would put squiggly brackets around those to show that this is a special list called the range. Another type of problem I might ask you to do is this one, where instead of giving you a table that's already filled in, I'm going to have you fill in the table. So if it says in the instructions that the domain of the function y equals 2x is 0, 2, 5, 7, and 8, then that tells me that that is the input values. So I would put the numbers 0, 2, 5, 7, and 8 in the row that says inputs. Now the outputs I need to calculate. And the way that I calculate the outputs is by plugging in the inputs. So it says here that my equation is y equals 2x. So if I take the 0 and I plug it in instead of the x, I get 2 times 0 is 0. Then if I take the 2 and I plug it in, I get 4. If I plug in the 5, I get 10. If I plug in the 7, I get 14. And if I plug in the 8, I get 16. Now that I have those two rows of my table filled in, I can easily list my domain and my range. So my domain would be squiggly bracket 0, 2, 5, 7, and 8. And my range would be squiggly bracket 0, 4, 10, 14, and 16. We're going to save example number 3 for tomorrow in case anyone needs help, and let's go ahead and move on to the next topic. So within this idea of domain and range, sometimes we're going to be looking at real-world problems. The idea is that in the real world, certain numbers are acceptable and certain numbers aren't. For example, if I said how many bags of flour can I buy from the grocery store, I would not be able to answer that question with a decimal. For example, I wouldn't be allowed to go into the grocery store and say I'm going to buy 1.5 bags of flour. They're not going to take a bag of flour and cut it in half for me. So certain types of numbers make more sense in certain situations than others. We're going to go ahead and list some technical names for different types of numbers now. And after we list those, we're going to talk about how to decide which numbers make sense in a given situation. So all of the numbers that we are going to talk about today are what are called real numbers. So just like you can have real friends and you can have imaginary friends, there are such things as imaginary numbers and real numbers. You're going to learn about imaginary numbers in Algebra 2. For now, we're going to focus on only numbers that live in the real world. So these are real numbers. Within the real number world, we have what are called rational numbers and irrational numbers. Now you can't be both rational and irrational. Just like you can't be both a freshman and a sophomore at the same time. You have to be one or the other. So rational numbers are going to be all decimals. All fractions. All whole numbers. All counting numbers like negatives and positive. Irrational numbers are just a few numbers. So the things that fall into the irrational category are what I call ugly square roots. Like, for example, the square root of 7 or the square root of 11, both of which would give you ugly decimals as answers if you tried to simplify them. And anything with a pi. For example, if I said your area was 3 pi, or 4 pi, if we were talking about a circle, those would be irrational numbers. Now, we're never really going to deal with irrational numbers. These don't come up as often in the real world. We're mostly going to be dealing with what are called rational numbers. And within the rational number category, we have some specific subcategories. So just like you could be a sophomore who has Mrs. Vasta for Algebra 1, or, a freshman who has Mrs. Vasta from Algebra 1, or you could be a freshman who has Miss Rizzi for Algebra 1. Within this category, we have some smaller groups of numbers that we're going to sort out. So within the category of rational numbers, a smaller category would be what are called the integers. Integers are nice round numbers, and they can be positive or negative. So that would be like -1, -2, 0, 1, 2, 3, ... That ... means keep going in a like fashion. So basically, as long as it doesn't have a decimal or a fraction, it gets to be an integer. Within the integers category, we have an even nicer group of numbers that we call the whole numbers. Whole numbers start with 0, and then we only use the positives. So this time we're not even having to deal with negative numbers. It's just all positives. When I give you a word problem and I say which of these types of numbers makes the most sense to use, you're going to go through a 3-step thinking process. First, you're going to decide whether it makes sense to use decimals in the problem. If decimals make sense, you're going to say that we want all of the rational numbers. If decimals do not make sense, then you need to keep thinking about what does make sense. If the second question is going to be decide whether positives or negatives make sense. Because sometimes a negative number doesn't make sense. For example, I can't go to the store and say I want to buy a negative amount of apples. That's not a thing. Then the last thing is you need to decide if there is an upper limit or a lower limit to your numbers. For example, if a stadium can only hold 100 people, you can't sell more than 100 tickets because there's not enough seats then. So let's take a look here. It says a theater has 100 seats. Right away when I read that, I go, okay, that's going to be important, the fact that there's only 100 seats. The formula f of n equals 5n minus 25 gives the amount of money the theater will earn for selling n number of tickets. So based on this formula, I can tell that my x values are being called n. Now it says, what is the domain of the function? Domain is asking me about the x values. So in this problem, since we're using n instead of x, it's asking me about how many tickets I can sell, since n represents the number of tickets. So if n is the number of tickets, and I want to think about how many tickets I can sell. Let's start with, does it make sense to use decimals? That's the first question on our list. Well, if I'm selling tickets, I can't sell 1.5 tickets. So I want no decimals. Does it make sense to use positives and negatives? Well, I'm not going to sell a negative number of tickets. So no negatives. And is there an upper limit or a lower limit? Well, if there's only 100 seats, I can only sell 100 tickets. So the upper limit would be 100. If I think about all of this information, question number 1, question number 2, and question number 3, and I want to decide what types of numbers should use. What I'm going to do is look back at my list of numbers and see if there are any numbers that are no decimals, no negatives. Well, if I look back at this list, rational numbers have decimals, so that's not it. Integers have negatives, so that's not it. But whole numbers have no negatives and no decimals. So I want the whole numbers. More specifically, I need an upper limit. I don't want to sell more than 100 tickets. So I would say the whole numbers less than 100. Let's take a look at a couple of examples here, because I know this is a little bit complicated, so we're going to go kind of through the thinking process again. Andrea is selling candles as a fundraiser. She spent $50 on supplies for making the candles, and she plans to sell the candles for $10 each. The functions of her revenue can be modeled by C of x equals 10x minus 50. The fact that there's an x in here tells me that my inputs are x's. What is the domain of her function? Well, let's see. X is how many candles she sells. So let's go through our list. First, are decimals okay? Well, I don't know anybody that I can buy half a candle from, so I want no decimals. Second, are positives and negatives okay? Again, I don't know anybody that I can buy negative amount of candles from, so no negatives. And is there an upper or a lower limit? Well, it doesn't say that she can only make a certain number, so there's no limit. She could sell 1,000 of these things if she wanted to. If I look back at the list of my options, the numbers that have no decimals and no negatives would be called the whole numbers. And since there's no limit, we just say whole numbers this time. Number 3 is an example of an SAT style question. It says a local theater sells admission tickets for $9 on Thursday nights. At capacity means how many it can have. So this is the maximum number of people. It holds 100 customers. The function m of n equals 9n represents the amount of money the theater takes in on Thursday nights, where n is the number of customers. What is the domain in this context? So if n is the number of customers, we have to think how many tickets we could sell. Our first question would be, does decimals make sense? Well, if I'm selling tickets to a theater, I would say there are no decimals. Second question is, do negatives make sense? Well, again, I would say no negatives, because I'm not going to sell a negative number of tickets. And is there an upper or lower limit? Well, this time, the capacity, which means the upper limit, is 100. So I would say that there is an upper limit. If I read through these options and it says all whole numbers, well, I can't say all whole numbers because there's a limit. All non-negative rational numbers. Well, rational numbers have decimals. That's not allowed. All non-negative integers that are multiples of 9. Multiples of 9 means like 9, 18, 27. I definitely don't have to sell tickets in groups of 9, so I'm not going to choose that one. All non-negative integers less than or equal, this should say equal to, 100. Well, that seems to make sense. Non-negative, so no negatives, integers, so no decimals, less than or equal to 100. The capacity is 100. All right, that's it for today. Thank you so much for watching. I hope you have a great afternoon, and I will see you guys tomorrow for some practice. Have a great day.